Hello again. Today we are talking about ionic compounds. So hopefully you remember that an ionic compound is the attraction between a metal, which has lost electrons, and a nonmetal, which has gained electrons, and then because of their opposite charges, they attract. Okay, so we're talking just for now about metals with nonmetals. So there are attractions between positive and negative ions. It's opposite attracts. You can think of them a little bit kind of like a magnet that can stick together but then come apart pretty easily. Electrons are always going to be taken from metals by nonmetals. So metals are always going to be positive, nonmetals are always going to be negative every time. So metals make cations. You can kind of think of, if you look at the word cation, it has a little plus in the middle, and then anions are negative. In an ionic compound, the number of electrons lost must always equal the number of electrons gained. So if you remember from the naming cards activity, sometimes you needed more than one of a particular element to make everything equal out. But you need to end up so that the charge equals 0. So the number of electrons lost is the same as the number gained. So here, this is just a little picture of the periodic table to remind you that this side is all the metals. Everything to the left of this stair-step line, that's the division between metals and nonmetals. So everything over here will be positively charged. That didn't show up very well, did it? Positively charged. Everything in this little tiny triangle will be negatively charged if it forms an ionic compound. Okay, so for ionic compounds, you're looking for elements that are on opposite sides of that stair-step line. We're going to talk about naming ions before naming compounds, because basically if you can name an ion, you can name the compound. For metal ions, there are sort of two different rules depending on the type of metal. For metals in group 1 and group 2, and for aluminum, their charge is fixed. They can only have one particular charge. So elements in group 1A always have a 1 plus charge. Elements in group 2A always have a 2 plus charge. Aluminum always has a 3 plus charge. So since the charge can't change, if you just know the name of the metal, you know what the charge is, because it's always the same. So to name the ion, you just have to name the metal, name the element, and then since this is just a sodium ion without anything connected to it, you just write the word ion. So it's sodium ion, strontium ion, aluminum ion. Okay, and you'll see when we name compounds, we'll just get rid of that last word. With all of the other metals on the periodic table, they can have more than one charge. Not at the same time, but they can make ions of different charges. We'll talk about why later on when we talk about electron configuration. So for now, just trust me that it happens. And because it happens, you need to have a way of indicating which particular ion you're talking about in a compound. So to do that, you use Roman numerals. Okay, so you put the name of the metal, the Roman numeral of the charge, and then the word ion if it's not connected to anything. So here would be iron 3 ion, iron with a 3 charge. Here is copper 2 ion, copper with a 2 charge. Iron can also make iron 2, copper can also make copper 1. So here's some other examples. You can see iron 2 and iron 3. There's copper 1, tin 4, lead 2. So these are all metals that can have more than one charge, depending upon how they've bonded, what they've bonded with, and so on. So to name them, you have to indicate the charge. You will either know the charge, because it will be an ion like this, and it will just tell you the charge, or we'll talk about how to figure it out based on what it's bonded with in a little bit. So, to reiterate, transition metals, which is basically all of this, and down here. Everything that's not group 1, group 2, or aluminum has a variable charge, so you have to name it with a Roman numeral. For anions are nice because anions also have fixed charges. So when we name them, we just change the ending to IDE, Ide. So this takes a little bit of practice to kind of figure out where to cut off the name. Usually if it ends in like gen, oxygen, nitrogen, you kind of take off the gen. For others, you just kind of sound it out. So here are 3. Oxygen always gains 2 electrons, so it's always a -2 charge. So it's oxide. Fluorine always gains 1 electron, so it's fluoride. Nitrogen always gains 3, so it's nitride. Okay. Just change the ending to ide. Okay, so there's just a few of the charges. A lot of these other ones that aren't in the little loop, they will tend to make covalent compounds. But they also, for our purposes, will follow whatever their group does. So, you must remember the charges or the oxidation numbers of the elements with fixed charges. So you'll need to know group 1 is always 1 plus, group 2 is always 2 plus, group 3 aluminum is always 3 plus, and then the non-metals are sort of in reverse order: 1 minus, 2 minus, 3 minus, and then 8 is the noble gases, so that's just 0, of course. Okay, so you do need to know those. You'll have a periodic table to look at, and that can kind of help you jog your memory, but you need to know them. So naming binaries, so 2 elements, ionic compounds, is almost the same as naming their ions. You just kind of get rid of the word ion, basically. A couple of things to remember. You always, always, always name the metal first. It always goes metal, non-metal. And then the non-metal, in these cases, are always going to end with ide. So if you just have 2 elements in your compound, you know that the ending will be ide. So that's handy. If you have a metal with a fixed charge, so you need to check and recognize that it's in group 1 or group 2 or aluminum, then you just name the metal, name the non-metal ion. So NaCl is one that you guys are probably all familiar with. Sodium chloride. That's all we put because sodium is always 1 plus. Chloride is how we would name the chlorine ion. Magnesium iodide. Magnesium is always 2 plus. And then iodine, when it becomes an ion, you call it iodide. So notice they all end in ide. So fill these out. And think them in your head. Okay, so I'm going to start writing the answers. So Na3N, Na is sodium, doesn't need any Roman numeral. N is the ion of nitrogen, so it's nitride. Sorry, I lost my stylus, so my handwriting's a little terrible. Potassium, always 1 plus. The ion of bromine is bromide. My D's are weird, sorry. Aluminum, always is +3. The ion of oxygen is oxide. Okay. Magnesium is Mg. And then S is sulfur, so the ion of sulfur would be sulfide. Sulfide. Okay, so notice, it didn't matter what any of the subscripts were. We didn't do anything with those. We just named the metal and then the non-metal ion. Metal, non-metal ide. Okay, so there you go. Let's look at my crummy handwriting. Okay. Now, these have variable metal ions. And this is something we'll talk more about how to figure out the charges a little later on, but I'll tell you now as well. So basically, you know that bromide is always 1 minus because it's a non-metal, it's a fixed charge. So if it took 2 bromines to take the electrons from iron, it must be iron 2 bromide. You can also kind of think of it like this. So FeBr2 is there. The subscript of bromine tells you the charge of the iron. And the subscript of iron, which is just like an imaginary 1, tells you the charge of the bromine, which you know, because it's always 1. Okay? Here, in this next one, we need 2 coppers to balance out 1 oxygen. You know oxygen is always a 2 minus. And so it must be, if it took 2 coppers, it must be copper 1. So this is one of the times that you do have to put the 1. Okay? If it's a Roman numeral 1, you have to put it. Because otherwise, you don't know. Okay? So you have to make sure you put a 1 even though it's a 1. Okay, SN is tin. That's one we'll learn. Chloride always has a charge of 1 minus. So it took 4 chlorides to balance out the tin. So it's tin 4 chloride. Okay, here, Fe2O3. Oxygen always has a charge of 2 minus. So if it took 3 2 minuses, that's a total of 6. electrons. So if we have 2 irons, each one must have given 3. Because 3 times 2 is 6, and 2 times 3 is 6. So this is iron 3 oxide. This next one, copper sulfide. Sulfide is in the same column as oxygen, so it's always a 2 minus. So if it just took 1 copper to give 2 electrons to sulfur, it must be copper 2 sulfide. So there you go, nicely typed versions of them. And we'll do lots of practice with this. This is one of the more challenging things that we do because you have to keep the rules straight and you have to make sure that you check what kind of compound you have sort of at every step of the way. So here's some more practice. I'll give you a little bit to mark or to mentally check. Okay, so calcium oxide. Calcium is in group 2, so it always has a charge of 2, so we don't need Roman numerals. So it must be 1. SnCl4. Tin is a transition metal. It can have more than one charge, so you need a Roman numeral. Okay. Chloride has a charge of -1. And so if it took 4 of them, it must be tin 4. Okay, cobalt oxide. Cobalt, you should know, is a transition metal as well. So just right off the bat, you should be able to eliminate these two because they don't have the Roman numerals. So you know it has to be that one. Okay. So there's the correct answers. Go ahead and check your work. And that concludes naming ionic ions, naming ions and compounds.